Hey everybody, this is Mrs. Ademeyer, and we are going to be talking about VSEPR theory today. Now I'm sure you looked at it and you said VSEPR theory, but it's actually pronounced VSEPR theory. I know it looks like VSEPR, but it is VSEPR theory. And what VSEPR theory does is it kind of tries to provide a 3D explanation for what a 2D picture is going to look like for a molecule. And honestly, for our molecules that we can draw Lewis structures for, VSEPR theory provides a really, really good way to predict what those things are going to look like in actual three-dimensional shape. And it helps us kind of work with, how different drugs and things are going to interact with each other and how molecules interact with each other. And it all comes back to this VSEPR theory. Now, VSEPR, VSEPR, actually stands for valence shell electron pair repulsion theory. And if you think about the words that make it up, valence shell electrons are the electrons that participate in bonding and that we draw in our Lewis structures. And repulsion means pushing away. So the kind of fundamental piece about VSEPR theory is that the shapes that we see are caused by the repulsions of all of those electrons and how they intermingle with each other. I want to kind of show you something. So I'm going to pull up my doc cam, and then we're going to take a look at it. So what I have here are two water molecules, and they're actually magnetic molecules. We use them for talking about molecular polarity and all that stuff. So what I'm going to do is I'm going to kind of show you what happens here. So these are magnetized, and the whites have the same kind of charge, and the reds have the same kind of charge. So if I take a white molecule, or the white end of my water here, and I bring it towards another white magnet part here, because they are the same charge, either positive or negative, and I'm not sure which one, they are going to repel each other. And just like magnets on a molecule here, you have the same thing happening. The bond that occurs between two different atoms happens because of a pair of electrons. And when I have a bunch of pairs of electrons around any given atom, those electrons want to repel just like this magnet wants to repel because it's the same charge. And so VSEPR theory kind of hinges on the idea that we are going to take those electron pairs and they're going to push as far away from each other as they physically can. And when they do that, they take up a specific shape that most molecules have kind of a prediction that we can make for. And so because of that, we're going to kind of play around with that in this PhET simulation. So when you guys get to the point where you're going to click on the PhET simulation, you are going to open it up and it's going to look like this. Okay, so you are going to see this PhET simulation opening here, and then you want to go in and click play. It's going to take its time opening up here, and you're going to get two different options. You are going to want to open it up to just the model one and not the real molecules. And then what you want to do is you want to click remove all. So all we want to do is start with a central atom here. And then as you're going through, you're going to want to make sure that you have molecule geometry clicked on and show bond angles. And so what we're going to do is you're going to be working through the activity by talking about the different things that you could potentially add to this purple atom here. Now imagine your purple atom is the center atom in your Lewis structure. So when we talk about these, it's the center atom and how many bonds are attached to it and how many unshared pairs. So for instance, if I want to add two bonds and a lone pair, what I would do is I would say that I have two bonds and a pair. In technical terms, we would call this 3 electron dense areas because there's an electron pair here, there's a pair of electrons in the bond, and a pair of electrons in the other bond. So this molecule here has 3 electron dense areas. 2 of those areas are coming from bonds, and another one is coming from a lone pair. Okay, so what you're going to be doing is you're going to kind of be going through and playing around with the different combinations that you see and recording the names and the bond angles for them. Then what we want to do is when you build them, and you get the name and you get the bond angle on them, we want you to take a screenshot of this molecule if you're able to. And if you can't, you can just hand draw the shape of it into the chart. And then you're either going to upload that copy of the document with your screenshots in there, or you're going to make the table on a sheet of paper and then take a picture of it and upload it into the assignment. And so what we want you to do is kind of play around with this. This simulation does a really cool job, and you can kind of keep adding bonds a lot. And what it'll allow you to do is kind of rotate the molecule, and you can kind of see the different shapes that you'll take. Remember that every area like this is an electron dense area. So in this case, we have 1, 2, 3, 4, 5 electron dense areas, and then you're going to get a specific shape for that. Okay, so you need to, like I said, identify the molecular geometry down here, which is also known as its VSEPR shape, as well as the bond angles that you see on this molecule. And when you're ready to start another one, because you've got one figured out, go to remove all and then repeat the process. Okay. If you have any questions, make sure you give your teacher a buzz, whether it's email or through the You Can Book Me or whatever, and we'll get things cleared up. Good luck.